Physics students, good afternoon. I'm Mr. Puget here. In this problem, we're going to be looking at something that we call power, which is closely related to what we've been doing with work and energy. So in this problem, this is going to kind of walk through problem number 15 on your homework over work, energy, and power. The problem statement reads as this. A student weighing 614 newtons climbs at constant speed to the top of a 12-meter vertical rope in 17 seconds. What is the average power expended by the student to overcome gravity? So, as we've kind of introduced in class, power is equal to work over time. It's a rate of change, effectively, of work. How much work is done in a given amount of time. So here, remember, when we're dealing with work, we've also defined work as a change in energy. So work could be a change, so power could be a change in energy over time. Or we could also define work as a force applied over a certain displacement. Either of those would be an appropriate way. And here, when we're describing power, we're looking at work done in a given amount of time. So if you read our problem statement, we're told a student has a certain weight, 614 newtons. They're climbing a rope that is 12 meters tall in a certain amount of time, 17 seconds. So to kind of give us a picture of what's going on here, something I like to start with, and here's our rope. The student is climbing. Say this is kind of our ground right here. We're told that rope is 12 meters tall. Now, in order for us to find the power that's expended by the student, we need the work done and we need a time value. How much work is done and how long it takes to do that work. Now, we're given a time value directly in our problem statement. My value I'm given is 17 seconds. But we don't necessarily know how much work is being done. We know the student's weight, but we don't know how much work is done to get him from bottom to top. Now, when we're dealing with work, there are a couple of ways we can approach work, right? Work is force, displacement, cosine of the angle between them, or work is equal to a change in energy. Now, in this scenario, we can tell that something is changing as we go from the ground up the rope. Obviously, our position is changing, so potential energy due to gravity is going to be the work, is going to be the energy that changes. And we're also told that we're going at a constant speed. So kinetic energy isn't really going to change here. It's really potential energy due to gravity. Now, we could use our approach for work is equal to a change in energy. The tricky part here is that we're not really given the mass of the student directly. We're more so told the student's weight. So what I'm going to do is rather than using our change in energy approach, which I will tell you, you can use that. And you can back solve, find the mass, go through that approach. That's okay. And I'm going to use our equation for force, displacement, and cosine of the angle between them. Because we're given a force and a displacement pretty clearly. So to find the work done going up the rope, here's what we'll do. I'm going to plug in the values that were given directly. So work done is equal to the force. Well, if I weigh 614 newtons, that's the force that's needed to overcome gravity, right? Because gravity is the force that's wanting to pull me down. I've got to overcome my own body weight to pull me up the rope. So that's the force that we're going to use, 614 newtons. Now, we have to apply that force, right, over the length of the rope, right, 12 meters. So I have a force that's overcoming my weight, going up a certain distance, displacement of 12 meters. Now here, we're applying a force the same way that we're moving. We're pulling up and we're moving up. Okay? So our force and displacement are in the same direction, which means cosine of 0 will be 1. So work done is 614 newtons, okay? It's our force, times 12 meters. I'm going to go ahead and plug that in and see what I get. And what I do, it looks like 7,368 joules. That's how much work is done in order to get us, effectively, up the 12-meter rope. Now, this question is not asking us for the work done, it's asking us for the power expended by the student. And remember, power is just a rate of change of our work. How long does it take to do that work? So power, P, is the work done over time. So I'm just going to take 7,368 joules divided by our time, which needs to be in SI units of seconds, 17 seconds. So 7,368 joules divided by 17 seconds. The power expended is right at about 433.4. And remember, our units for power are watts. And a watt is just a joule per second, in case we've forgotten. And it's just the units that we use to measure power. So hopefully that gives us kind of a little bit of a better idea of how to approach this idea of power, work done over time. And if you have any questions, don't hesitate to let me know. Hopefully this will get us working in the right direction. Good luck.